We have two methods to solve an exponential equation. The first one is preferable, and we want to use it if possible, and that's to write both sides with the same base. Such as example 4, 3 to the x power equals 81. We know that it would be easy to write 81 as a power of 3, so we could write it as 3 to the 4th power. And then once the bases are equal, we set the exponents equal. So if that's possible, we definitely want to use that method. But if we look at an example like example 5, we know there's no way to write 3 and a 14 with the same base. So here we need the second method. And the second method is to use logarithms. So when we use logarithms, that actually can take two forms. We can either use the definition of a logarithm, or we can take logarithm of both sides, and I'll show you what I mean. Okay, so on example 5, so the first way here is to use the definition of a log. This is the most direct way. So I can write this as an equivalent equation using logs. Remember, the base of the log is the base of the exponent. So my base of my exponent here is 3, so the base of my log is going to be 3. And then we take log base 3 of 14, and that's going to equal the exponent. Remember, the logarithm is always equal to the exponent of the base. So right here, we solve for x. Now, if we want to actually evaluate this, we know our calculator can't do a bases besides 10 and e, so we use our change of base formula to write this as log 14, or natural log 14, over log 3. So then if we want to evaluate on our calculator, we want to enter log 14 divided by log 3, and we can approximate, so that's approximately 2.4. So x approximately 2.4. So you may be asked to approximate to so many decimal places, or they may ask for the exact answer. Okay, so another way to use logarithms is to take the log of both sides. So, or we can take log of both sides. Okay, so if we want to use this method, we know that if we have an equation, we are allowed to take the log of both sides and maintain that equality. So I could take log or natural log of both sides, so log of 3 to the x power is equal to log of 14. Now, we've got to get this variable out of the exponent. But now that that variable, that exponent, is on an argument of a logarithm, we have a rule that lets us move this out in front. So we have x log 3 now equals log 14. And then all we need to do is divide each side by the log of 3 to isolate x. So we have x equals log 14 over log 3, which is exactly what we got over here. Again, we know that's about 2.4. So either way is correct. But if you want to just make a note that here, in example 4, we can write both sides with the same base. So if we can do that, that's preferable. But on example 5, here we can't. We can't write both sides with the same base. So we must use logs.